All right. Hello, everyone. Thank you for joining us today. Today, we'll be listening to Eric Stein, who received a BSEE degree from the University of Kansas and is the founder, principal, and chief electrical engineer of the Engineering Studio. He has over 25 years experience in the design of plumbing and fire protection systems for commercial, residential, and retail projects. Eric is a registered member of the National Council of Examiners for Engineering and Surveying and a registered professional engineer in 8 states. In addition, he's a member of the Electric Association Consulting and Electrical Engineers Division. If you have any questions during this talk, you can put them in chat or raise your hand. Feel free to ask questions and I'll give it away.
Hey, good morning. Happy Saturday. Thanks for joining, and it's good to see you all. So I will talk today about my engineering career and how I got started and what I do as part of my career. And so we'll keep this pretty informal. If you have any questions at any time, either raise your hand or put it in the chat or whatever, or just speak. I'm pretty informal here. And I want to make this interesting and get to things that you guys want to know. As William said, I have a double E degree, so electrical engineering, bachelor's, and what I do is I would call my part of the engineering field, I would call it architectural engineering. And so that means that the systems that I'm involved with are related to architecture, related to buildings. So everything every system that you have in a building, so if you go into a school building, let's say, there's lights, there is air conditioning, heating, there is plumbing, and then there's other specialty systems, fire alarm, there's fire sprinklers, there are audio speakers, all of these systems. And so that's what we call architectural engineering. All the mechanical and electrical systems in a building that integrate with the architecture of the building. And so that's what I do as an engineer. And the point of our engineering is to create the drawings and the plans that show the design and allow the contractors to build the building. And so that's in a nutshell what we do. Now I'll back up for a second just to say how I got to where I am. Okay. So my engineering career it goes all the way back to when I was a kid. And it comes from a curiosity of how things work. And so, some of my earliest memories from age 3 or 4 are playing with Hot Wheels cars, but also taking them apart and swapping tires from a truck to a sports car or whatever. And so ever since I've been young, I've been really curious about how things work, no matter whether it's a mechanical thing, an appliance, an electronic circuit, how does a light switch work? I've been curious about that all my life. And I think it's just something, it's just how I'm wired inside. So that's one of the attributes to an engineer is curiosity for how things work. And maybe that develops into a passion for how to make machines work better, and machines in a real general sense, whether it's something you would think of as a machine like a car, or an electronic circuit, or an airplane, or any number of other things. And so going forward, everything that I did growing up was really related to that interest. So in junior high, I was in wood shop and metal shop, creating things, creating projects. That's really been my interest. In high school, I was in auto tech, working on cars, and I was also in calculus, AP. So, I had that math and science kind of background. It just comes naturally. And then, my hobbies in high school had to do with centered around cars mostly, but also electronics. At that time when I was growing up, car stereos were a big thing. Believe it or not, cars came with an AM/FM radio at that time. And so, the hot thing was to install a cassette player or speakers or whatever. And so that involved wiring and understanding how the circuits work. So going into college, then engineering seemed like a natural fit, both from a testing standpoint. You may have taken or maybe you will be taking a career test in high school that takes your interests and tries to tell you what might be a good fit for a career. So engineering seemed like a natural thing. Someone that is interested in math and science, good at it, but also with an interest in how things work and how systems can affect people. So I went to Kansas, University of Kansas, for engineering. Kansas is a good engineering school, and it was close to my home. I grew up in Overland Park, which is a suburb of Kansas City, Missouri. So, so Kansas was a good program, and so I started in the electrical engineering program there. And Kansas, for electrical engineering, that's their specialty is signal analysis. So that means radio signals, radar, sonar. Those are their areas of research. And so a big part of our education was analyzing waveforms, the sine waves or other types of waves that electrical circuits can generate. And so I started in that. In sophomore year, there was a brand new program called computer engineering, which was essentially chip design. And at the time, that the chip was the Motorola 68000, which is the chip that they used in the first Apple Macintosh computer way back in the 80s. So that was our focus. So I was in that. I switched to that because it sounded interesting. By the end of sophomore year, I realized that circuits were not really what I liked to do. For me, the engineering was always related to hands-on. And for me, circuits were not as interesting, it turns out, because I couldn't see what was going on. It was see electrons moving moving through the circuit. So it became less interesting for me. But at the time, I was halfway through engineering school, needed to stay, focused in order to get the degree. So, but it was at that time that my college counselor introduced me to architectural engineering, and KU has a program there, and it's run by the School of Architecture, but it involves the systems that are in buildings. So power systems, which would be lighting, outlets, that type of thing that you see, in any building, heating and air conditioning design, plumbing design, structural design is another part of that. And so I was introduced to that. I realized that's what I would like to do. But unfortunately, having completed 2 years of school, if I switched at that point, I would have added another year to my school. So at the advice of the counselor, I stayed with the double E degree, finished it up, knowing that I wouldn't go into signal analysis and circuits. I wouldn't be working in a lab, which is really what that degree training was. But I would change, to the architectural engineering career. So there really wasn't any big deal when I did that. Electrical background was in the double E degree. There's plenty of education to be able to do the architectural power engineering, I guess I would call it. And so I came to Chicago, started working for a design firm, and that was right at the very beginning of when the drawings that we were making were changing from hand drafting to computer drafting. So that was in 1989. And up until that time, the plans for buildings were hand drafted. And they were just starting to use computer-aided drafting, CAD, for making the drawings. And so that was really interesting. It was a really interesting time to be in that field. And so I started hand drafting essentially, and quickly moved to the computer drafting. And so that was the beginning of that field for me. And so since then, it's been a matter of learning about the different types of electrical systems that go in buildings. And I've also branched out to do plumbing systems, to do fire sprinkler type systems. And so over the course of my career, I worked at three firms before I started my own company in 2000. I have a partner. So I have a partner who's a mechanical engineer. He designs the air conditioning and heating systems. And so we started in 2000. And the buildings that we design could be apartment buildings, everything from, let's see, sorry, I was looking at the chat. Here, let's see. William says, what advice would you give to someone deciding what field of engineering to go into? Okay, very good question. It's a really personal choice about what kind of engineering. So that's why I told the story of how I bounced around a little bit in electrical engineering, computer engineering, back to electrical engineering, and then even a different kind, maybe related architectural engineering. So you have to think about what you're passionate about and what interests you. I think the other thing that I would say, I'm going to talk about it in a minute. The other thing about engineering is that there's different kinds of engineers. There are lab engineers. There are people-related engineers, and I'll talk about that in just a minute. I think that's an important influence on the type of engineering that you would do. So I'm going to finish up with what I'm doing, which is the different kinds of buildings that we would design the systems for. That would be, say, for residential type of buildings, we might do anything from a 3-flat building to a 30-story building with apartments, with amenity spaces like, could have a pool, a fitness center, dog walk area, all of these different types of areas that you have in a modern, large apartment building. We also work on schools. So whether that's remodeling a school, doing additions to a school. I actually worked on project at the Latin School back in the 90s. So I can't even remember exactly what we did, but I think we did an addition to the building at that time. But we work on a variety of schools, whether they're in the suburbs. We've done charter schools in the city, all sorts of different school work. Offices, you think about all the offices in Chicago, and whether it's a lawyer's office, accounting office, doctor's office, anytime those offices are created from empty space or they're expanded or remodeled, there are designs to be done. And other interesting types, there's all sorts of different types of buildings to be designed. We've designed a commercial horse racing facility out in the suburbs. We've designed greenhouses at the Chicago Botanic Garden. There's so many different kinds of buildings, and that's what makes it really interesting for me is to see all these different types of buildings, to see how the people use the buildings, whether they're the owners or the tenants or the customers, and to see how our systems will relate and to help those people get what they need from the building. So that I guess covers basically what we're doing. Let's see here. Let me say the product that we produce are plans, whether they're paper plans or PDFs a lot of times. And the plans, drawings that show the design, they specify the equipment, they show, for example, what size the ductwork is that goes from the air conditioning unit to the register that's in the ceiling, or they show what kind of wire goes from the light switch to the light. The plans and drawings serve two purposes. One is they have to be turned into the city for a permit. So you have to have a construction permit to build something. So they use our drawings for the plans examiners to review those and to say, yes, the design meets the codes that are out there, and you have a permit to build this. And then those plans and drawings go to the contractors or the builders who are actually doing the building. So somebody is out on the site with their wire and looking at the plan saying, okay, we're going to run this wire from this spot to this spot. And so it's the purpose of what we do, and that's our product. As opposed to, a commercial type of product, we build whatever, it's, our product is the drawings. Let's see. I was going to ask, what was your favorite project to work on? That's an interesting question. There's a lot. I have several favorite projects. One interesting project was when we did the engineering for a very large house in the suburbs. And when I mean very large, I'm saying 30,000 square feet, which is roughly 15 to 20 times the size of a normal house. And this was this house had an indoor bowling alley. It had an elevator. It had a helipad on the roof, and it had a small racetrack around the house because the owner of the house was part owner in a NASCAR team, and he had his own car in one garage that he would drive around the circle track around his property. It was probably 10 acres of property. So that was a really interesting project for me because, trying to imagine living in a place with all of those types of things. They had an indoor pool and an outdoor pool. And so that was a really interesting project. Another interesting project would be greenhouses at the Chicago Botanic Garden. If you've ever been there, you know how many different plants they have, different trees they have all over the grounds. So what our project was, this particular project was greenhouses where they cultivate those types of plants before they go out and are planted in the public grounds. So it was really interesting to learn about the different types of plants and the different types of greenhouses because they have different environmental conditions that are required. So that was really interesting. Trying to think of another variety. The first high-rise project that we did in the South Loop, 30-story building. Really interesting to see just because it's such a big building, and to the first time I imagined myself being part of a team designing a 30-story building. It was just the sheer size of the building made it interesting, and different types of systems that are there and the amount of people that it would house eventually. We went on to design multiples of those types of buildings, and so those are really interesting, and I think a source of pride just because of the size and complexity. Let's see here. Okay, another question here. What does the day-to-day look like at one of the firms you work at for starting your own? Okay, so day-to-day. Okay, so this is a good question. This will get into what I wanted to talk about a little bit, was the types of engineering that you can do. If you think about what's the stereotypical view of an engineer, and when I think of that, I think of somebody maybe in a lab coat, working in a lab on a project, and I'll use circuits as an example. That's sort of how I think. They're working on a circuit board, and they've got their oscilloscope and other screens in front of them, and they're designing. And overall, it's sort of like isolated presence there. You know, as an engineer, you're working on something, you're designing your part. Maybe it's one part of a bigger machine, but the stereotypical view of an engineer would be, I think, lab oriented, maybe, and not necessarily interacting with a lot of different people. However, what I've found is that there are different kinds of engineers, different kinds of engineering. And so in my field, because we're not working on a product, we're, like a machine or an appliance or something. We're working on a set of plans, which the whole point of the plans is to communicate to other people. And these plans have to communicate to the plans examiner. They have to communicate to the builder, and they also have to communicate to the owner to show that we're designing what they want, that the systems are going to function the way they want. They're going to be able to control the lighting or dim the lighting the way they want, the way they imagine. And so my part of the engineering field is a lot of interaction with other people and with non-technical people. That's the biggest difference, I think, between different kinds of engineers. So a traditional engineer I think of as interacting with other engineers for the most part, other technical people. What I found in my part of the field is that most of my interaction is with non-engineers, maybe even non-technical people. Many of the owners that we work for are really non-technical. And a big challenge in our part of the job is to be able to explain the technical systems to a non-technical person. And so that takes a certain type of personality and a certain type of knowledge. So I see that as a difference. There are engineers that are very focused on design and the technical aspects. And there are engineers that are more focused on explaining the design in a way that other people can understand it in order to buy into it. So no matter what field of engineering you're in, there's going to be a point where the engineering has to be explained to a non-technical person or sold to a non-technical person. So whether you're trying to sell your product, whether you're trying to get funding for your product, or in my case, you're trying to explain how you've met the requirements of the project to the other person. And so for me, I have discovered over all this time that although I'm an engineer and I have a technical, analytical mind, I am also really interested in the personal relations and how engineering can accomplish people's goals and affect their lives. And I'm probably more interested in that than the actual design. And so that's what I've discovered over this time of, especially of owning my own company, that while the design, of course, is important, for me, my focus has been on explaining the design and listening to the client to understand what it is they want, translating what they want into technical terms so that a design engineer that I employ will actually design it that way. So, so those are different kinds of personalities. And as you go into engineering, you're going to determine what type of personality you are, what you like to do, and you're going to find your path. So, so not only is it the type of engineering, whether you're doing mechanical or aerospace or electrical, there's the subject matter that you have to decide what excites you and what interests you. But you also will eventually have to decide where you fit in the engineering field. Are you focused on design? Are you focused on managing engineers in design? Are you focused on selling the design or evaluating the design? And so as you go along, you'll find your way. Okay, so now to get back to William's question, what does your day-to-day look like? Okay. So in my field, everything is project oriented. We do multiple projects at the same time. So we have different buildings in design, different stages of design. At the beginning, at the end, they're being constructed. We're looking at what's constructed to see if it matches the design. There's this whole range of things. So day to day, I would have, let's say, 3 to 5 projects that would be in different stages of design. So I have to multitask. And on one project, we're at the beginning of the design. So we're doing calculations to determine what size wire, what size electrical service we need, what size water service we need for the building. And so we're counting up the number of lights, the number of outlets in the building. We're counting up the number of sinks and toilets and so forth, and putting that into a calculation. And so that might be on one project. On another project, we're in the middle of producing the drawings. And so we're using our CAD programs to insert on the drawings the symbols that represent the different light switches, outlets, piping, ductwork, that type of thing. And on another project, we are in construction. So somebody is building off our plans, building the project, and they have questions. So there's always questions. And, so those are submitted to us. And they refer to this drawing. You say, put this size wire from here to here, but we can't, there's no route to get that way. There's structural in the way, or the ceiling is too high and we can't get the wire that way. There's all these different types of questions that could come up. So we would be answering those or interpreting. Maybe we wrote a note on the drawings that we thought explained what needed to be done, but somebody reading it didn't understand it. So they're asking a question, well, what did you mean by this? So we're answering that question. And at the far end of the spectrum would be a project that it has been constructed. The builder says, it's pretty much done. We want you to come out and take a look at the project. So we go to the project, which is basically done, not yet opened. And we walk around and we look at what's been constructed. We compare that to the design on the plans, and we issue a report, which will say, yes, it looks like it's all been constructed per the plans, or there's this area that was not constructed properly and needs to be changed, or something was done that doesn't meet a code requirement. So day to day, there's multiple projects in different stages. And so there's a lot of different processes going on there. And that's what I find interesting about it. A lot of different processes, different types of projects, interacting with different type of people. Phone calls from the architect. What did you mean by this? How big is this object we're trying to fit? What size room do you need to fit your equipment in? That type of stuff. Let's see. What would you say is the most important thing to focus on now as high schoolers who want to go into engineering? Okay. So if you want to go into engineering, then at this point, number one focus would be school, classwork. It would be your math and science classes to focus on. And I would also say to focus on communication. English class, writing. In my part of the engineering world, we write a lot of reports. We write a lot of emails to explain. As I've said, a lot of our work is explaining what we're doing to non-technical people. And so communication is really important. And I think that it's going to be important in just about any engineering situation, because typically engineers will have to explain what they're doing to somebody at some point. Now, you might be explaining to another engineer and you can speak in technical terms, and that may be all you need to do. But at least in my experience, communicating with non-technical people is a big part of it. So certainly math and science, of course, are important and the most important, but communication is also important to succeed, I think. Let's see, what's the most irregular design you've worked on? Let's see. a lot of different kinds of projects that, I mean, it's really interesting because so many projects are actually, each project is different. And so while there are similarities in apartment buildings, let's say, there's a lot of similarities, but there are irregularities in just about every project because of the particular site that we have to build the building on, or the particular users or owners' preferences. So I would say one of the most irregular projects we had was we designed a very large house. I'll call it a house, but it was in Lincoln Park, so it wasn't really a traditional house. It was more like it was a 4-story building that you might think is an apartment building, but it actually was just one person's residence. And so it had a lot of really specialized systems in it. And the irregular part about that was that the owner said, I want to be able to get parts to maintain the systems myself. I want to be able to go to Home Depot and get all the parts to maintain the systems myself. And it was very difficult to explain that the type of building and the type of systems that were required to accomplish the other parameters. Okay, so in this house, this building, he had what was irregular. He had a prized bird, some sort of African parrot, giant bird, and the bird had its own room. And so it had a special room, and it had its own air conditioning system just for that room, and a filtering system because of the feathers. So not only did they have this very expensive prized bird, but the wife was allergic to the bird. And so we had to design the whole building around the fact that the bird had very specific tropical conditions that had to be maintained in his room. And we couldn't have any of the air get up into the house because of the allergies. So that was really unusual. And then on top of that was the husband saying, I want to be able to go to Home Depot and get all the parts to maintain the systems myself. And it was really complicated. And essentially we had to explain to him that just wasn't possible. And he wasn't going to be able to maintain the systems himself. And he wasn't going to be able to buy the parts at Home Depot because it was very specialized, commercial grade equipment. Essentially, we were building like a lab, something that was so tightly controlled. And you just can't do that with normal household equipment. So that was a very irregular project, not only from a design standpoint, but from a communication standpoint, because it was very challenging to explain those types of things when someone had in their head that this is what they wanted. They're paying for it. And if they're paying for it, they can get it. Whatever the cost is, doesn't matter. But if they're paying, they can get what they want. And we had to try to explain that just wasn't possible, that any amount of money wasn't going to be able to accomplish that. And so that was irregular and challenging. Okay. What is first year of work like for an engineer who just got out of college? Okay. The first year is a lot of learning. So you're going to go through high school and college. You're doing mostly technical courses, of course, and it's hard. Engineering school is hard. No matter where you go, it's going to be hard. You're going to get through it. You're going to feel like you've learned a lot. The first year of work after college is learning how to apply what you learned in college. And and my experience is that it's very different. When you look back on college, you see how theoretical it was. Um, and even if you'll have labs, you'll have real world experiences, maybe an internship, and that can help to bridge between the theoretical and the actually what we do. And so the first year, I think, is it's a combination of things. It's exciting because you are going to get to do something with all that education, and so it's exciting and it's fulfilling to do something with all the study. It's also a little confusing because it's a lot different than school. Work is a lot different than school. And so there'll be different processes, different other outside factors. You know, in school, it's all focused on the design. And I think that unless you have a really good internship that shows you the real world application, I think school is very theoretical. You're focused on your design. You don't really have to deal with outside factors, practical factors that might affect. When you're doing your design in your lab in college, you're not really concerned with funding, let's say, or some project manager's vision of how it should be. And when you get to the work world, there are other factors that will influence the design. So what you find out is that you can't just be in a vacuum doing your design, that there are other factors. There's a time frame that might be unreasonable. There might be funding. There might be a pandemic, whatever. You know, there's all these different things that could come into it. So the first year is a combination of learning and learning what factors influence actual work, and also just, I think, being excited about actually producing something after all of the training. Let's see, was finding a job difficult, and do you think it would be difficult today? So when I came out of school, finding an engineering job was not difficult, especially in Chicago. Lots of engineering jobs. So that was however many years that was ago, 30 plus years. I think today, these days, finding an engineering job, I don't think it's difficult, because I think there is a huge shortage of engineers in all the fields. And so with the last, whatever it's been, let's say 10 years push on STEM in schools, we're getting some more engineers. In my field, in particular, in the architectural engineering, there's a huge void of engineers coming into the field. So we've had this problem for probably 10 years. There's not enough engineers coming out of school, and most of the engineers go into more high-tech type of engineering than the architectural engineering field. So I've had a really hard time finding people to hire, new people, young people to hire. There's not enough coming into the field, and even older people that are either leaving the field to go work at Google or some other sort of high-tech type of place, or a management type of place. So in architectural engineering, for example, there's a huge shortage. So overall, I do not think it will be difficult to find a job as an engineer. Let's see, what goes on during an engineering job interview?
Oh, Mr. Stein.
Yeah. Yes.
Not to interrupt you, sorry, but like it's kind of related to that question.
Yes.
But more like personalized. Like, what would you look for when you're hiring somebody, or like?
Oh, okay.
Stuff like that.
Okay. This question, what goes on during an engineering interview? That's what you're saying. That one is more personal to me.
No, I had a question that was like similar to that.
Okay.
Like that one's I don't know if it was more generalized, but like I want to know like what you look for when you're hiring people.
Well, what do I look for? Okay, sure. Um, we can do these two questions at the same time. So what goes on in an engineering job interview? What do I look for? That's going to depend, first of all, on the level of engineering that we're talking about. So let's just use a first job, coming out of school type of interview as our example. So for a first engineering job, the focus is going to be on what education did you have? Did you have an internship? What type of extracurricular activities did you have? And do any of those relate to a technical or engineering type of interest? Not to say that it's not good to have other interests, because it is. It is good to have other interests that have nothing to do with engineering. So I think that initially it's going to be sort of a technical abilities type of interview. And if I was interviewing for a young person just graduating from college, I would be looking for someone that, first of all, has an interest in technical type of subjects. Believe it or not, there are people that go all the way through engineering school who are very smart and can do the engineering, but are not that interested in it. And that's what that's what's really surprised me, is that I do know people, even in my own field, that are really not that interested in how things work or how to improve systems. They're focused on the career, the salary, that type of thing. They're smart. They can do the work, but they're not passionate about it. And that's one thing that's always really surprising to me, because engineering is hard. Engineering school is hard, and to go all the way through it without being passionate about it is somewhat amazing to me. So when I am looking to hire somebody, especially in my field, I'm looking for someone that is interested and predisposed to think that way, to think about, how does this work? Well, how can I improve it? Those are sort of natural instincts, I think, that engineers should have. Not all engineers do have it, but I think it helps a lot. I would also look for good communication, personable interactions, the ability to express yourself, to be open to discussing different ideas, to debating the merits of one design versus another, to understanding the other person's point of view. There's in any design, there's different ways to accomplish the end goal. There's pros and cons for each design, and in the end, it's a compromise. Whether it's a compromise in the design features, it's a compromise in how much they cost, it's a compromise in how much space they occupy. There's a lot of different compromises to be had. So I think that communication and the ability to talk through the design, even explain how you got to that point in the design, that's important to me. In my particular field, architectural engineering, if we're doing the electrical design, HVAC design, which is heating, ventilation, air conditioning, The math is not super difficult. We're not using calculus as an example. So from that standpoint, the how well you understand calculus is not necessarily a factor in what I'm looking for. You have to be technical, but it's not the most technical type of analysis that you could do. If you're doing another type of engineering, you might be using calculus all the time. But in my particular field, we're not using that. So in place of that high level of math and science knowledge, I would be looking for more communication skills in my so in an engineering job interview, that's what I'm saying is it could vary quite a bit. It really is going to depend a little bit on the engineering career that you're going into. It may be very technical, and it may be more personality and communication based. Let's see, if architectural engineering weren't an option, what field would you have pursued instead? That's very interesting. I think that for me personally, if the architectural engineering was not an option, I probably would not be in engineering. I would be in something else, business or law. What I've found from running my own company is that I like the entrepreneurial aspect of it, and I like the people aspect of it. So that's just me personally. What I've found out is that I have an engineering degree. I certainly have an engineering analytical type of mind, but there's a limit to how technical I want to be. And there's other things that interest me. So this is actually a good subject, because there are a lot of engineers who do engineering for a while, and then they switch to something else. There are engineers that go to law school because the analytical type of mind that you need for engineering, you can apply that to other fields. There are a fair amount of engineers that go into patent law, copyright, patents, that type of thing. And because you have a technical background, you can read technical type of descriptions of products and so forth, and do the analysis that might be necessary to look at a patent infringement case or something like that. So there's a fair amount of engineers that do go to law school. Many of them go to patent law. Many of them go to other types of law. But there's also business analysis. You'll find engineers that go from engineering. Let's say you're at a corporate type of engineering company. There are engineers that go from the design into the management, into the finance side of it. And I think that in financial analysis, there's that analytic component. There's also the math component, of course. And so there are other areas that you might go into. So some engineers start as engineers, end as engineers. Design, that's what they want. There are other engineers that start in engineering. They move to management, where they're managing engineers. Maybe they move to sales. So it's going to depend on your personality and what you like to do. And for some of you, being in a technical field but not necessarily being a designer will be the right thing. And that's certainly fine. There's room for all sorts of people. So I hope that answered the question there. So I think I covered all the parts, everything that I was intending to cover. And so are there any other questions that anybody wants to ask? Okay. All right. Well, I really appreciate the opportunity to talk to you all. And I think this group that you're in, it's really terrific. It's a great opportunity. I didn't have this opportunity. I didn't really, I just went into engineering sort of as a college counselor at the high school said, well, look at your scores, look at your interests. You should be an engineer. Made sense at the time. But I think that you guys are listening to different engineers and their experiences, and it will really help you narrow your focus to what type of engineering you want. It also may encourage you to be a generalist and wait for a while to decide, what type of engineering you want to do, or if you want to do something different than engineering. There's always that possibility too. So I think it's really good. I encourage you to keep attending these sessions with the different engineers. You're going to get a different perspective, hopefully, from a lot of different engineers, and help you to make your decision. So thank you.
Yeah, thank you so much for your time and your perspective, Mr. Stein. Other than that, I think we're going to wrap it up. Thanks, everyone, for coming, and have a great weekend.
All right. Thank you.
Thank you.
Bye.
Thank you.
Thank you. Thanks, Mr. Stein. Have a good weekend.
Sure. Thank you. You too.